Okay, so the last couple of lectures we've been discussing the endgame for a medium mass star like our Sun. We discussed the first red giant stage, then the next one is the yellow giant, when the helium in the core is fused into carbon. Eventually all of that helium is used up and the carbon core is formed, and the star is not simply massive enough to squeeze the carbon core and heat it up so that nuclei heavier than carbon can fuse. And basically that's the end. What happens next is that the thermal pressure and also the radiation pressure of the central object, they push on the top layers and move them out. They form so-called planetary nebula, this shell, spherical shell of gas, or material, I should say, of the star. And what is left behind is this dead, meaning it's not producing energy through fusion any longer, carbon core with some admixture of oxygen nuclei. And that is what white dwarfs are, right? So let's now discuss in more detail remnants of a medium mass star. They are planetary nebula. They're composed of the star's material that is pushed out by the thermal pressure and radiation pressure during the final red giant stage. Okay, so we have this spherical shell of material that is pushed out by pressure, right? It's moving out. Okay, so this is a planetary nebula, right? It's moving out. And what is left behind is this dead, meaning it's not producing energy via fusion, carbon core. It forms what is called white dwarf. Remember I said that it's possible for a carbon nucleus to fuse with another helium nucleus and form the nucleus of oxygen 16. These are the remnants of a medium star, of medium mass star like our Sun. Now, let me give you a few examples of planetary nebulae. Okay, this is the famous ring nebula. So we are viewing this edge on, right? Basically, it looks to us as if it was a donut, but it's really a cross-section of a spherical shell. Turns out that more light is coming from this region here, that is the slice that is perpendicular to our direction, to the direction which we are viewing, and therefore we get more light from it than from the rest of the shell. So we perceive it as a donut, but it's really a cross-section of a sphere, and I'll explain that in a moment. And then let's look at another one, and this is a Helix Nebula. The reason they are called planetary nebulae is because when you view them from a small telescope, these images that I've shown were obtained through quite powerful telescopes. But if you use a small telescope like the ones that people used in early days, when you look at them, they appear to have bluish-green color, the same color as the color of planets Uranus and Neptune, and hence the name planetary nebula. Okay? The name has nothing to do with planets or planet formation. It's just that historically, when they were detected for the first time, these fuzzy objects, their color looked just like the color of those distant planets, Uranus and Neptune, and therefore they were called planetary nebulae.